In this session, we're going to see how to find the slope between 2 points. Before we develop a formula in general, let's look at a concrete example. Here we have 2 points whose coordinates are 1, 1 and 4, 3. Slope can be considered as rise over run. In other words, in going from the point 1, 1 to the point 4, 3, how high up do we go? That's the rise. And how far do we go, in this case to the right? That's the run. And the rise is referring to y coordinates. So the rise going from 1 to 3 is an increase of 2. So the rise is 2. And I've drawn that in green because it's a positive change. The run in going from 1 to 4 is again positive, and in this case it's 3. So the slope, being rise over run, is the ratio of 2 for the rise to 3, which is the run. So the slope is 2/3. We denote the slope using m for reasons that are beyond me. Suppose we wanted to start at 4, 3 and end at 1, 1. In that case, the rise, I'll kind of put that in quotes mentally because it's negative, would be down, and the run would be to the left, and so it's also negative. So I've done that in red, and we see that the rise, quote unquote, is -2, and the run in the negative x direction is -3. The slope would then be -2 over -3, which simplifies to the same 2/3 that we had. And when a line goes up to the right, as this one does, that's a positive slope. If it had gone, say, down to the left, that would be a negative slope. Now let's see what this is using symbols. Here we have an xy plane, and I have here a line that has points. We'll call them P and Q. And let's say P has coordinates x1, y1, and Q has coordinates x2, y2. So in going from P to Q, we can consider the rise and the run. Using the coordinates, the x-coordinate for P is x1, the x-coordinate for Q is x2, and the y-coordinates are y1 and y2 respectively. In considering the rise from P to Q, I'm indicating in blue y2, I'm indicating in red y1, and the rise, delta y is how we refer to that, is y2 minus y1. The triangle in front of the y, as I said, is delta. It's a Greek uppercase letter delta. Delta in this case meaning difference, and it's there because we have a difference of y coordinates. Likewise, if we take all of x2 and subtract off x1, then we have the difference, which we refer to as delta x, and it's x2 minus x1. The slope being the change in y over change in x, which I'm indicating triangle y over triangle x, or delta y over delta x, is the difference in the y coordinates, y2 minus y1, divided by the difference in the x coordinates, x2 minus x1, and this is our slope formula. For our first example, we're going to find the slope between P, which has coordinates 3, 1, and Q, which has coordinates 4, 3. As usual, I like to label coordinates, and for P, I'll label 3x1 and 1y1. And for Q, I'll label 4x2 and 3y2. Now our slope formula is change in y over change in x, so y2 minus y1 over x2 minus x1. And it doesn't matter which of P and Q I give the 1s and the 2s to. What matters is that the 2s are together and the 1s are together, And in the slope formula, whichever one's first in the numerator must be first in the denominator, hence the y2 minus y1 over x2 minus x1. Well, fleshing out this formula means that we have 3 minus 1 in the numerator and 4 minus 3 in the denominator, and this simplifies to 2 over 1, which means the slope is simply 2. We're going to follow this up with another example. We're going to find the slope between p, which is 1, negative 3, and q, which is 4, 3, and I have my reasons for putting it all on the same screen here. Well, the slope formula is the same. I'm going to label for p, 1 is x1, and negative 3 is y1, and for q, 4 is x2, and 3 is y2, and then our slope, being rise over run, is going to be 3 minus negative 3. We have to mind our negatives here. And for run, we have 4 minus 1. Now let's look at that numerator for just a moment. The first minus is built into the formula. The second minus is because the coordinate is negative. That's what I mean when I say mind our negatives. Well, simplifying here gives me that the slope is 6 over 3, which means that the slope is equal to 2. Notice we have the same answer. Let's see what these look like on a graph. When we consider the first pair that we had, 3, 1 and 4, 3, I have them on the graph here, and the slope is rise over run. So here I see that the rise is 2 and the run is 1. In keeping with what we had here a minute ago, the slope is 2. Now let's consider the other pair, 1, negative 3, and 4, 3. I've plotted 1, negative 3, and we also have 4, 3, and the rise between these two is 6. The run between these two is 3, and so the slope, being the ratio of rise to run, 6 over 3, is also 2, as we got before. And as it happens, these 3 points are on the same line. And so what we would say is that for any 2 points on this line, the slope, rise over run, is going to be 2. Here's what I'd like for you to try on your own. Find the slope between p, which is negative 2, 5, and q, which is 2, negative 1. For p, I'm going to label negative 2 as x1 and 5, y1. For q, I'm going to label 2, x2, and negative 1, y2. And remember, slope is y2 minus y1 divided by x2 minus x1. And so, to flesh out this formula, we have negative 1 minus 5 in the numerator, and 2 minus negative 2 in the denominator. And so our slope is going to be negative 6 in the numerator, 4 in the denominator, which reduces to negative 3 halves. Now let's see what would happen if we had reversed everything. In other words, if I had said that the slope in the numerator here is y1 minus y2, and in the denominator is x1 minus x2. I had said it didn't matter which one goes first, the ones or the twos, as long as whatever is in the numerator is matched in the denominator. This just means we're going to switch the coordinates in the numerator, and so we're going to have 5 minus negative 1 as our change in y, and negative 2 minus 2 as our change in x, and in the numerator we end up with a positive 6 and the denominator a negative 4. Notice that the fraction reduces to the same number, negative 3 over 2. Okay, so here I've plotted the 2 points, negative 2, 5, and 2, negative 1, as well as the segment that connects them. And let's see, negative 2, 5 was p, and 2, negative 1 was q. And if we go from p to q, then we're going from 5 to negative 1. That's a change in y that's negative. And going from negative 2 to 2, that's a change in x that's positive. Now remember that the slope is the ratio, change in y divided by change in x. And if one of these is negative and the other one is positive, then the ratio is going to be negative. If we decided instead that we wanted to go from q to p, then the rise from -1 to 5 would be positive. The run from 2 to -2 would be negative. And that would give us a slope that is still a ratio of positive change in y to negative change in x that turns out to be negative. Here we have our last two examples. Find the slope between 4, 7 and 1, 7, and find the slope between -3, 4 and -3, 9. Why don't you work these out on your own? Okay, as a reminder, the slope formula is m equals y2 minus y1 over x2 minus x1. So for the first example, y2 minus y1 is 7 minus 7. x2 minus x1 is 1 minus 4. So the slope that we get is 0 over -3, which means that the slope is equal to 0. A quick little sketch here indicates, let me label y and x, that if the y coordinates are both 7, and I don't care what the x coordinates are, then we have a horizontal line. There's no rise. For the second one, m equals, now y2 minus y1 is going to be 9 minus 4. x2 minus x1 is going to be -3 minus -3. Again, for those minuses in the denominator, that first minus is because of the formula. The second minus is because the coordinate is negative. But in this case, we have that the slope is equal to 5 in the numerator, 0 in the denominator, and so this slope is undefined. And notice I don't put an equals sign. It's not equals undefined, it just is undefined. And again, a quick little sketch here. Let me label y and x. If both of the x coordinates are -3, now again, I don't care what the y coordinates are, they're right on top of each other. This is a vertical line. Horizontal line has no rise, and so the slope is 0. A vertical line has no run, and so the slope is undefined. And here I've summarized the four possibilities. Up and to the right, positive slope. Down and to the right, negative slope. Horizontal line, 0 slope. And vertical line, undefined slope.